Hello friends, today I am going to talk about AWS Glue. As I have already explained in my previous videos that AWS Glue is a very important serverless ETL service that we use for data ingestion as well as data manipulation. Now in this session, we are going to have the hands-on lab experience of how do we configure AWS Glue to ingest data from a source system, which is MySQL database in this case, and then how we are going to export this data into Amazon S3. In this lab, the format would be Parquet format, which is a highly compressed data format which is there. If you have not seen my other videos on the architecture side, please do visit in the playlist AWS Serverless Data Lake. The link is there in the description of the video also. Before we go to the actual lab, let's first understand what we are going to do in this lab itself. In our source boundary, we are going to have one RDBMS database, which is a MySQL database. Now this database I have already created, and in this database I have one table which is also already created there. So the name of the table is console underscore CSV. We will be creating the ETL job, which is a glue job that we will be creating, and we will be sending this data onto the S3. So in the S3 side, I have already created a bucket and a list of folders which are also already created there. So I will give a walkthrough of those folders also. There is one important thing which I mentioned about earlier is the catalog, glue catalog. So glue catalog is what maintains the schema, the meta information of the files which you are going to export from the RDBMS and ingest into the S3 bucket. This glue catalog will also get created as part of this ETL job execution, and this will then help to execute query. So you can execute the query also to see that what all data are available, what all data has been exported inside this Parquet files. So that query, when you execute, that query has to be Athena query. Athena is the SQL interface through which you can write and execute the query on a semi-structured file like CSV, Parquet, ORC, TXT files which are stored in your S3 bucket. Another very important concept that we would be showcasing in this POC is also the partition. So let's now go back to the demo section. What is the schema of this table? So it has got various fields around the sales data, shipping data, the unit price, those kind of things, and UUID is the, I'm assuming this is a unique ID which is there. Now if you want to see all the data, select star from console underscore CSV. So these are all the 899 data rows of data which are there in this. So this database is running on Amazon RDS, and we would be fetching the data from this table and sending it into the S3 bucket. Now how we are doing it? Let's first see the S3 also. In the S3, as I mentioned earlier, there are different folders which are there. We would be looking into this input, and within input there is the raw. It's completely clean. There is no data in this raw. Let's quickly start and create a ETL job. We start with the source. So in the source, you have to understand from where you are going to get the data. So in our case, it's the relational DB from where we are going to get the data. Now, this is the connection which I have created earlier, Glue Workshop MySQL connection. But I will tell you what exactly is this. So you can create the connection. I will just explain how you can create it. So you go to the connections link on the left hand side, and you can click on the create connection. You will get different options which are available there. You can select as per your own requirement. For example, if you have a database running on EC2 or in your data center, you can select JDBC, and you can go to the JDBC thing, provide all the required information like the JDBC URL and driver class, and where exactly is that driver available, those kind of things. Similarly, if you have suppose Amazon Redshift or Google BigQuery, you can connect to them also. Same way, we had this Amazon Aurora or the RDS which we were talking about. So if you have those kind of database, you can just go there and you can see those databases which are already available. And Glue Workshop, which was already configured as a RDS database, so that's why it is available here in this. In the meantime, I will change the name also. Glue ETL Lab 0. I also have to select an IAM role. I will tell you later on what is this IAM role and why it is required. But for now, just understand that an IAM role is needed. And here you can see that the type of the ETL job is Spark. It is already selected there, and this version and everything is already selected. I have selected the latest version which is available. And what is the worker node type? So minimum is a 4 virtual CPU and 16 GB RAM. So we will go with that. How many workers you need? We don't need to 10 workers. I think 2 is good enough. 2 is the minimum that we have to select. And number of retries and everything, that's fine. It's not required at this point of time. So now the job has been saved based on the database connection which I have given here, which I have selected. It is going to the RDBMS, which is our RDS relational database service from AWS. So you can see that the schema detail is now available from the source database, and we can see the data also uh, that it is populating well. So whatever we have given in the configuration, things are all fine. Now we have to go and select action. You can see here that there are different action which are available. You can change the schema, you can join multiple source files, you can write a SQL query, you can kind of check the quality of the data, you can check on the missing values. If there are duplicates, you can add logic here to drop those duplicates. For this example, we are not going to do all of any of this. So we just we just take this select fields. So select fields is whatever data is available in the source, it will take that and send it to the destination. So just some random name I am giving here. You can see the parent node. So the parent node is this console CSV it has already taken. Now which all fields you want to send? Suppose I select all of them. So it will select all of them to send it to the target. So you can see this is the target. This is the output of the schema which will be sending to the target. If you remove some of those information here, then this sales channel order priority would not be available here. So you can see that the sales channel order priority, those three fields are not available. So that's the reason that you can deselect the fields which needs to be there in the target. And finally, the same data which you will be getting here also, which you saw earlier. And now the last one is the target. So in the target, our Amazon S3 is the target. We are going to have the data into Amazon S3 bucket. What is the parent for this? The parent is the field selector. What is the format? We are going to have Parquet as a format. So you can see there are multiple formats which are available here. We will be going with the Parquet. There are different compression algorithms which are available there. You can select any one of them. Let's go with the default Snappy, which is available there. Now S3 target location, we just search for Glue Workshop. In the Glue Workshop, there is an input folder. Within the input folder, we have the raw folder. So now we will not go inside the raw folder. So because raw is the last folder, the file needs to be created within the raw folder. So that's the reason we have now selected the raw folder. Now, how do you want to update the data catalog? So data catalog update are generally required when you change the schema of the data, or you create different partitions, you update the partitions, those kind of things. So I will explain that partition also here, but before that I select this one, the create a table in the data catalog, and on subsequent runs update the schema and add new partitions. So if in case there is a change in the schema, it will update the schema, and if there are new partitions which are getting added, it will add those partitions also into the Glue catalog. So that is very important while talking about this one. Now, if you remember in the Glue catalog, I mentioned about databases that very similar to RDBMS, Glue catalog also has databases. So here also we are going to have the database which is console Glue Workshop. This is our database which is going to be there. What is the name of the file? The name of the file is console CSV. So we will keep the same name, or we will prefix it with a different name. So I'm just giving a different name, raw console CSV. Now finally you see that it is asking you for a partition key. This is all optional, you don't need it, but partition key, understand it in a slightly different way. Now this is the bucket. Within this bucket, you are going to have the folder, and it will have multiple folders. You can have tree like a structure. Now, how do you send the file? You can send the file and you manage the file in terms of date time, right? Or you manage it in terms of, suppose customer data is there, so customer ID. Or you manage in terms of market segment. So these are the different fields which are there inside your data itself, in the schema of your data. Now what these fields are and why these are important: when you do the processing, whether it's a Spark job or a Hadoop cluster and the big data processing, they are all based on the principles of parallel processing. It means that you divide your data into multiple fragments so that these jobs can run in parallel at the same time across the different segment of the data. So instead of having one bulk data like this, you want to partition this data into parallel area. So your data would then be residing within those specific boundary, those specific partition areas. The more you have the partition, the more you will have the flexibility to run more and more parallel jobs into it. But if you do not do it, what will happen is that first thing, you will have a restriction on the number of parallel jobs, and that will have an impact on the execution time, performance, everything. Second thing is that every folder in the S3, it has got its own throughput limitation. So if you have all the file in a single folder, your processing would then be constrained by the throughput of that folder. But if you scatter and distribute your data into multiple folders, you are getting the multiple throughput. So if you have 10 folders, you are going to multiply 10 into the throughput of each folder. If you have 5 folders, you are going to multiply 5 into the throughput of each folder. So the more you have the folders, the more you are going to have the throughput available for you. And what these folders are, these are nothing more than a partition. The second thing is that whenever you are doing any SQL query, any fetch, any update, any kind of processing, you are scanning the data. Now S3, one of the price component in S3 is also the scanning of the data, how much data you are scanning. So if you have one big directory, one big folder, and within that folder, if you have most of your data, then every time you run your job, it is scanning all the data, and that then create additional cost for you, because the more you scan the data, the more you have to pay for it. But if that same data you distribute into multiple folders, into multiple partitions, then for a specific query, you know the boundary of that folder, that what is the minimum and what is the maximum value of the ID which is available there. And that is the reason I said that the partition key identification is very important. That how do you define the partition key? Because the partition key only tell you that in this specific folder it is available between 1 to 10. In this folder it is available between 11 to 20, like that. So if that field is suppose UUID, so if your job logic should have the UUID in the where clause, because then only it will know that which folder it has to go and scan for. If you do not have this logic, then what will happen, even if you have your data scattered and distributed across different folders, you would be scanning each and every folder. So this kind of design thinking you have to bring forward, and that is the reason I was telling that I will explain the partition concept with an example. So now let's go back to the browser. Let's add a partition key here. Now these are the different fields in your schema. You can select any one of them as a partition key. If you select UUID, most of the record is going to have unique UUID, and this is a very good candidate here in this case. Date is one thing there, because date is something which is going to be unique across many of those data. So you can go for date also, that would be all fine. So let's select date and see exactly how it is going to behave. This is the output schema which you have already seen earlier. Data preview is not available because S3 we don't have any data and it doesn't support on the S3. So that's the reason data preview is not available. But up to this part we are all fine. Let's first save this job, and then we will see exactly that how this job is going to create the data into the raw folder. Our job has now started. When the job is running, you can go to the job run, and here you can see this the latest row. It is saying that the job is currently running. You can go to the CloudWatch logs also, and you can see the view run detail also. So view run detail, it will take some time, but this log data would be available on a real time basis here also. You can now see that the log has started being created here. The initialization of the cluster, its creation, everything is taken care by Glue only. We don't have to do anything. And once the job is done, then Glue will stop the cluster, and you would only be paying for how long the Glue job has run. So you can see that now the logs are available here also, and it is getting executed. Even on the basis of partition also, it creates the bookmark. So bookmark is a concept where whatever the last process data is there, it marks that data. Now if you want to run this job every day, it needs to know exactly that what was the last record up to which it has already processed, and that is where job bookmark is very important. I think the job has been finished. Let's just go. Yes, the job has got executed. You can see it has used 2 nodes, and it has utilized 0.07 hours of the time. That is what it has taken. This is the S3 bucket, and as I mentioned earlier, within the S3 bucket we had this input folder. Within input folder we have the raw. So you can see here that it starts with the month, then it goes to the date within that month, and then year, and this is what the file is available there. So this is a Parquet file. This is the Glue catalog for the databases. Now inside this you can see we created this table which has the name of raw console CSV. Within this table you can see the partition. So the partition is like this. You can see the different partitions which has been created. There are so many folders which has got created, and that's why when you go for big data processing, you will have multiple jobs running in parallel. If you go to the tables, if you say view data, it will tell you that you need Athena to preview the data, and there will be a separate charge for that. So Glue catalog provide the schema information to Athena, and Athena then run that data. So if I suppose remove this thing here and run it again, now you can see here this is the AWS data catalog, and this is the namespace. From within that namespace you have this database console Glue workshop, and within that console this is the table that we have created. This table is the one which is actually providing all the detail. So you can see it's a very similar to the SQL query, and what it is doing is it is going to the Parquet file within each of the partitions which are available there, and it is then fetching the data from that Parquet file. So that's how it is there, and you can see that all the 899 records has come here. So that's how do you ingest the data from the source RDBMS into the data lake. So what we did today, just a recap of that. We have the source RDBMS. Within the source RDBMS, we created a ETL job, which is a Glue ETL job. This ETL job had the source configuration, then action configuration, and then target configuration. So this configuration we did where source is the RDBMS, action is just a mapping of the fields, and target is our S3. We already have S3 bucket, and within the S3 bucket we had folders which were there. Now while defining the target, we also defined the glue catalog that we did in this lab. So we created the glue catalog. What we created in the glue catalog, one is the database. So database was already created for this lab, and within this database we created the table. So this table schema is exactly mapped to what we defined here in the target configuration. Partition, we selected date, the transportation date as a partition, and because of that it created multiple folders for each of the unique date, and it moved the data as a Parquet file into that partition, into that folder to which it belongs to. And finally, when we say that we wanted to see the data also which has been stored in the S3, glue catalog took us to Athena, because Athena is actually a SQL interface to look into the S3 data. Athena looks into the S3 folders in all those Parquet files across all the partitions, and it provided us the data. In the next session, I'll be talking more about the data processing part, which means that your data has now reached the raw bucket. Now you do the processing on that raw bucket, and finally you generate the output out of it. I hope you have liked the video. The things have become more clear to you now, and let's join in the next session, which is more on the data processing using Glue ETL. Thank you, and have a nice time. Thank you.